Good evening, Mr. Shan. Good evening, everyone.
Good evening, sir.
Evening.
How are we doing today?
Tired.
Not bad.
Okay, cool. Well, if you're tired, it means that you're alive. Not bad is a very good thing. I trust that you are well, and I trust that you are ready to go. Because I am. And let me just get into this chart here. Okay, so Asia is here. Daniela is here. Doubting that is. Is Leonie here? Yes, she is. And Asia. Davia. Is Davia here? Davia isn't here. All right. So we're going to go into rounds of presentations, and I'm going to ask that you. Yeah, I did say to you what it is that you do. Each group is required to prepare a 40 minutes presentation. If you don't go up to 40 minutes, it's neither here nor there. So you don't, but of course you can't go over 40 minutes, or else I'll cut you off. Joking, but no, we need to respect the other group. And I already gave you 15 minutes, well, call it 20 minutes now, time enough for people to get on. At 7 o'clock, there were only 3 students, including myself, in class. So I gave you enough time to get here. At the end of the presentation, rather, each group is required to circulate a copy of in the WhatsApp group. Each member of the group is present, and the due date was the 22nd. Apologies for what happened. I don't know what happened, but I know I sat up. Know I sent off the stuff. Really don't know what happened. I use WhatsApp web, and I guess things just happen somewhat in the web. All right, so without any further ado, group 1, can you go ahead for me, please? Groups 2 and 3, I'm going to ask that you pay attention, because you may not know just yet, but all 3 groups have information that are intertwined, and hopefully some answers can be answered tonight. All right, let's go. Group 1, take over.
Or even if David isn't here, we should still go.
Oh yeah, absolutely. Yeah,
Okay, sir. No, don't need sharing screen? Or me to share?
What is saying, Asia?
No, sir, I'm asking Downing if she's sharing her screen.
Oh.
Or I'm...
Can you hear me clearly?
Clear as mud.
Good evening, everyone.
Evening.
Today we'll be looking at the new observations and the modification of existing theories. Our group members are Carol Campbell, myself, Leonie Garden, Davia Button, and Aja Holt. This is just an overview of geology itself. So I'll read. Geology is a core discipline of the earth sciences and encompasses many different phenomena, including plate tectonics and mountain building, volcanoes and earthquakes, and the long-term evolution of Earth's atmosphere, surface, and life. Because of the ever-increasing demand for resources, the growing exposure to natural hazards, and the changing climate, geology is of considerable societal relevance. A modern geological theory of tectonic activity, according to which the Earth's crust is divided into a small number of large rigid plates with independent movements relative to one another called deformation, volcanism, and seismic activity along their margins. So, in today's class, we'll be focusing on some of the world's renowned geologists. They are James Hutton, Charles Lyell, Alfred Wegener, ENGE2301, and George Cuvier. Without further ado, let's get into it. Okay, so first one is James Hutton. Scottish farmer and naturalist James Hutton is regarded as the founder of modern geology. He made it his life's work to investigate how rock formation and coastal erosion affect the way that land and seas and planets change through time. The world is significantly older than previously believed, according to Hutton's research. James Hutton's controversial figure was condemned by the church and the scientific community because he asserted that one only had to look at a rock to demonstrate that the planets are millions of years old. His claims were that the rock formation doesn't happen overnight, or in the 6,000 years the church claims is the age of the earth, as well as the theory of some scientists that the earth formed as a result of a biblical flood. He described in his words to be, and I quote, nonsense. Each layer of a rock reveals the changes the rock has gone through during its development and what materials have learned to follow the rock, creating a chronicle of the geological history of our planet. Now, I'm a video showing the great mind of James Hutton.
Was everyone here in the beginning of the video?
Yes.
When you look at a rock, what do you see? Well, you probably see what I see. A rock. Gray, brown, maybe a few sparkles. Nothing too exciting. But to 18th century geologist James Hutton, rocks were more than just rocks. Instead, they were the keys to Earth's history. Billions of years of stone shifting, melting, crunching, twisting, and reforming. A history that he discovered in a time when most people believed that the world was 6,000 years old. James Hutton was born in Edinburgh, Scotland, June 3rd, 1726. He was a bit of a floater, studying at several universities throughout his youth. This wasn't a big deal. He had a pretty large inheritance and several farms and was able to live comfortably without finding a specific trade. According to his teachers, he didn't like math very much, but he did have a strong interest in chemistry. He qualified as a doctor and wrote his medical dissertation on the circulation of blood, which he believed correctly, but for the wrong reasons, was being constantly destroyed and renewed. Eventually, Hutton decided that he didn't really want to pursue medicine. He spent some time on his farms, and then he moved back to Edinburgh in 1768 and began to develop his ideas about geology, which also involved renewal and recirculation. In Hutton's time, a lot of people believed that Earth was shaped by catastrophes, like the ones in the Bible. But Hutton thought that Earth actually went through a constant cycle of destruction and renewal. He proposed that rocks and soil are eroded and swept into the sea and then compacted into bedrock before being twisted and turned by enormous pressure. A few years after he first came up with this theory, Hutton discovered evidence for it in a few different rock formations. The most famous of these discoveries was at Sicker Point, a cliff off the eastern coast of Scotland that features layers of red sandstone and greywacke, a darker type of sandstone. The layers were sitting on top of each other, but they were also running in layers perpendicular to one another in what we now call an angular unconformity. He hypothesized that only great amounts of time and great pressure could have offset the rocks, much longer than 6,000 years. And as we now know, of course, he was right. This feature at Sicker Point and several others around Scotland are called Hutton's unconformity in his honor. He also discovered that granite was an igneous rock formed by the cooling of molten lava. By observing tendrils of granite that had made their way into rock like sandstone, which he realized could only have happened at very high temperatures. Hutton believed that this was strong evidence that there was molten rock below the surface of the Earth, and that this molten rock was constantly pushing outward and then melting again. He published his findings in a paper in 1788, but his theories didn't always gain traction because they often contradicted the idea that the Earth was 6,000 years old. Plus, a lot of other scientists' geological theories incorporated the Great Flood described in the Bible. Hutton's ideas did not. But a lot of his work turned out to be accurate, even though he didn't have access to technologies like carbon dating, which would have put actual numbers on the ages of rocks. Hutton also paved the way for future scientists, like 19th century British geologist Charles Lyell, to develop a theory called uniformitarianism. Uniformitarianism is the idea that the processes that shape the world now also shaped it in the past. So, scientists can work backward and figure out what happened in the past. By assuming that natural laws function in the same way across space and time, we don't need major catastrophes to explain how Earth formed. Instead, we can show that it's the result of slow processes over enormous spans of time. Thanks to Hutton, the picture of our world got a lot more complex. He was wrong about some stuff, but many of his ideas helped shape geological concepts that we still use today. Not too bad for a guy who's famous for saying that the Lord should pity the backside that is, and I quote, clagged to a head that will hunt stones. Thanks for watching this episode of SciShow, which was brought to you by our patrons on
Charles Lyell. Charles Lyell, a British lawyer, is one of the founding fathers of geology. According to biographers, Charles' eyesight issues were among the key reasons he decided against becoming a lawyer, which prompted him to start his career as a geologist. Also, at his college, which is Oxford College, a lecturer, William Buckland, which is a well-known paleontologist and geologist, was another reason why Lyell decided to venture into the career of geology. He created the uniformity theory, which was just said, which claimed the processes throughout history, not natural causes, were responsible for the development of the Earth. We now have a short video on Charles.
From the creation of ice ages to the effects of global warming, the Earth's climate is a roller coaster of change. And our next great discovery helped put it all into perspective. For centuries, people believed that the Earth was shaped by catastrophes, like the biblical flood. But in the early 1800s, an Oxford-educated lawyer named Charles Lyell shattered that belief and revolutionized geology. Lyell spent years traveling the world, studying an overwhelming number of rock formations and fossil samples. He had a brilliant eye for detail, and piece by piece, he began to see that the rocks told a different story. While catastrophes such as volcanoes, earthquakes, and floods occasionally affected the planet, the greatest changes were the result of an incredibly slow and natural geological process. A process driven by wind, water, erosion, and the heating and cooling of the Earth. A record of those changes was contained in the layers of rock. But here was Lyell's most radical insight. The mechanism for that slow process of geological change was time, lots of time. The Earth, Lyell argued, was far older than was generally accepted, and he presented proof of his findings in a landmark book called Principles of Geology. Today, its publication is considered the birth of modern geology. Sam Bowring is a professor of geology at MIT.
I think very important in Lyell's development of thought was a trip to see the volcanoes of Italy, and Vesuvius, I believe, in particular, where he actually saw that the mountain was built up of successive flows, and they had some of these, had a good idea of when they were erupted because they were historic, and he was able to use that to extrapolate that the volcano itself must be hundreds of thousands of years old, and at the time, talking about hundreds of thousands of years was revolutionary. Others argued for a directionality in evolution, that the Earth on day one is not the same as the Earth today. Some secular change has occurred, and this is a debate that geologists have today. Were plate tectonics operating 4.5 billion years ago, or is it something that developed later on in Earth history?
Today, many consider Charles Lyell to be the Charles Darwin of geology. In real life, the connection between the two men was significant.
Darwin took the first edition copy of Volume 1 of Lyell's treatise on his cruise with the Beagle. And what he realized from reading this, as he was also simultaneously worrying about evolution, was that here was the solution to evolution. We had limitless time.
Lyell's discovery set off a firestorm of interest in determining the true age of the Earth. Until then, most everyone believed that the planet was young. But with the publication of Lyell's seminal book, geologists wanted to know how young. Our next great discovery, from the creation
Alfred Wegener. The hypothesis of continental drift was first forth by German geophysicist and meteorologist Alfred Wegener. Despite having a degree in astronomy, Alfred chose not to work in the field. Instead, he went into meteorology, where advancements in storm tracking and forecasting were being made quickly thanks to the telegraph, Atlantic cable, and wireless. When Alfred published a book in 1912 with the information he had gathered to support his theory that the 7 continents have not always existed where they do now, he caused a stir in the world of geology. This new notion was termed continental displacement by him. He made a comparison between the continents and icebreakers, large rock ships that slowly ripped through the ocean floor over a long period of time. Additionally, he claimed that some 300 million years ago, the continents were all joined together into a single supercontinent he called Pangaea, which is a Greek word for all land. This is a video that will give a more deep explanation as to what was said before.
Alfred Wegener proposed a theory in 1912 that the great continents of the Earth had drifted over geological time and were once all joined together in a giant landmass we now call Pangaea. His idea was based on the way the present continents fit neatly together, and by the way bands of fossil-bearing rocks join up across continents like this. Unfortunately, Wegener was unable to provide a mechanism for this movement, and his theory was ridiculed by the scientific community until 1965, when the theory of plate tectonics was published. This proposed that the continents were moved around on great plates driven by convection currents in the hot mantle of the Earth. For details, see our related video. Perhaps the most dramatic evidence came from the magnetism of rocks each side of the mid-ocean ridges. When rocks solidify, they become weakly magnetic in the direction of the Earth's magnetic field. However, every few million years, the Earth's magnetic field flips, so the north magnetic pole becomes south pole, and vice versa. And this change is signaled in the rocks. Scientists found that the rocks each side of the mid-ocean ridge were magnetized first in one direction and then in another, like this. Magma solidifies, locking in the magnetism. New magma forms as the plates move apart. The magnetic field reverses. More magma solidifies, locking in the reversed polarity, and so on, creating a pattern that repeats each side of the ridge, with the rocks getting older the further you are from the ridge. Clear evidence of the ocean moving apart over millions of years. Further evidence came from plotting where Earth's volcanoes and earthquakes were situated. From this map you can see that they form lines around the globe, marking out the edges of the great tectonic plates. You get almost all earthquakes and volcanoes at plate boundaries. And finally, we find the great mountain ranges right alongside where two plates are pushing into each other. The Himalaya are being thrust upwards as India moved and is still moving slowly into Asia. And as the Pacific plate is subducted under the Asian plate, the islands of Japan, with many earthquakes and volcanoes, and the deep ocean trench to the east were formed and are still being formed.
ENGE Lehman. ENGE Lehman, a Danish seismologist, born May 13, 1918, made a stunning discovery that the Earth has a solid inner core. ENGE and other scientists rely on seismic waves, which are shock waves produced by earthquakes and explosions that move throughout the Earth and across its surface, to disclose the structure of the planet's interior because of the intense temperatures and high pressures on the planet. Lehman laid the groundwork for a 1936 paper, in which he proposed that the Earth's core was divided into two parts, a solid inner core encircled by a liquid outer core, separated by what is now known as Lehman discontinuity. This theory was based on a significant earthquake that occurred close to New Zealand and Lehman's interpretation of the data. Her hypothesis was confirmed in 1970 when more sensitive seismographs detected waves reflecting off the solid core.
So ENGE Lehman's discovery came in the 1936, in the same decade in which a discovery of Pluto was made. But instead of taking telescopes and turning them towards the sky, she took a seismograph, and in a mode of a telescope, she turned it towards the center of the planet, where she discovered the existence of the inner shell in the center of the planet.
One of the amazing things about ENGE Lehman is that she wasn't looking for the inner core, but she was very open in looking at the data. She saw some extra wiggles, some extra vibrations, which were reflections from the inner core.
So a lot of fundamental properties of the Earth can be better understood if we really know what's going on inside the core.
ENGE Lehman's discovery provided a basis for a later understanding of how the Earth's magnetic field is generated. And without that magnetic field on the Earth's surface, life would be impossible because it protects us from harmful cosmic radiation.
Because of ENGE Lehman's discovery of solid inner core, we can study the connection between the deep interior and the surface where we live.
Today we're hoping to peer into the core of Mars as well.
As we look to the future and we start exploring other planets, a seismometer has just landed on Mars, and we will only have a few recordings, just like ENGE Lehman. We'll have to use the same very simple techniques she used and start making the big discoveries that she made about the Earth. Does Mars have a core? Is there a fluid or a solid inner core? We'll have to make just those same discoveries with just the same simple techniques.
George Cuvier. Baron George Cuvier, born August 23, 1769. Died May 13, 1832, Paris, France. He was a French zoologist and a statesman who established the sciences of comparative anatomy and paleontology. As a staff member at the Museum of Natural History in Paris, he published a book called De Les Règnes Animaux Distribués d'après son Organization, 1817, which he described his theory of the correlation of parts, in which every animal organ is functionally related to all the other organs, and that an animal's function and habits determine its anatomic form. Anatomic meaning it would like body or the structure of the organism. So basically they say like the function and the habit of the animal determine the anatomic form. Cuvier's classification of all animals into 4 completely discrete groups was a significant advance over the system of Carolus Linnaeus. He applied his functional concept to the study of fossils, postulating that huge land upheavals and floods were the principal factor in the creation and destruction of species. Though the theory did not last, Cuvier's work put paleontology on a firm, impartial foundation. As Napoleon's inspector of public instruction, he helped establish France's provincial universities, and he also served as chancellor of the University of Paris. Here's another influential scientist. This is a video on Charles Darwin, biologist born 1809 and died in 1882. As you can see here, he spent 5 years on the HMS Beagle.
And we'll be skipping this video for now to save time.
Professor Dave here. Let's talk.
What is theory and why it is important? Theory is an orderly, integrated set of statements that describes and predicts behavior. Theories are influenced directly by cultural values and belief systems of their times. They guide and give meaning to what we see. When a researcher investigates and collects information through observation, the investigator needs a clear idea of what information is important to collect. Thus, valid theories are validated by research and are a sound basis for practical action. Examples of 3 theories in geological change. Theories of geological change set the stage for Darwin's theory, and there are 3 theories of geological change. These are catastrophism, gradualism, and uniformitarianism.
Theory of gradualism. Gradualism in geology refers most broadly to a theory that changes of organic life and of the earth itself occur through gradual increments, and often that transition between different states are more or less continual and slow rather than periodic and rapid. Gradualism has been ascribed to the manner in which Darwin inferred the origin of one species from another over geologic time, or the transmutation of species. How theories changes. A scientific theory is a test explanation of why things happened and is accepted to be true. This knowledge has been through rigorous testing that demonstrates it is reliable explanation of the phenomenon. If this is true, why do scientific theories continue to evolve? Because science is an ongoing process. As new observations are made, new ideas are developed to explain them. Theories are continually improved or modified as more information is gathered, so that the accuracy of the prediction becomes greater over time. Theories more than 10 years old are usually out of date, so any new evidence that supports a change prompts scientists to modify earlier theories. Scientists uses theories to develop inventions or find a cure for a disease. Role of observation. Observation is something we often do instinctively. Observation helps us decide whether it's safe to cross the road and helps to determine if cupcakes are ready to come out of the oven. Observation is more than simply noticing something. It involves perception, becoming aware of something by means of the senses, and the recognition of the subject's importance or significance. Observation plays a significant role in geology. Geologists notice features and properties, example, patterns, grain size, and the relationship between minerals of specimens. They collect and record data, and these observations provide clues about the geological processes describing the conditions in which the rock was formed. These observations also enable them to construct and then test hypotheses and theories. Theories. Developing theory is an ongoing process, a continuum. Existing theories can be updated based on new evidence and adjusted when applied to new contexts or developments. Our engagement with old classical theories brings them back to life and puts them to the test.
The theory is continued. Theory change is a community process of feedback, experiment, observation, and communication. It usually involves interpreting existing data in new ways and incorporating those views with new results. It may depend on a single definitive experiment or observation to change people's views, or it may involve many separate studies, eventually tipping the balance of evidence in favor of the new theory. The process may take some time since scientists don't always recognize good ideas right away, but eventually the scientific explanation that is more accurate will win out. So firstly, before we go any further, I'm pretty sure everyone here knows about Sir Isaac Newton, you know, the man who had an apple fall on his head and he subsequently discovered gravity, or, so the story goes. So Newton, Sir Isaac Newton, he came up with some important information that we call the Newtonian laws. But even though that he came up with all the laws and the theories, another well-known scientist, Mr. Albert Einstein here, he questioned these laws of motion. So Einstein's theory of relativity explained how the Newtonian laws of motion didn't remain true when objects traveled at or, near the speed of light. So the example of Newton, Einstein, and quantum mechanics is an example of the modification of an existing theory. So Newton was wrong. He was wrong. He just didn't have enough information. So his ideas still didn't hold up when we apply them to a falling apple or dropping a car keys. That's all the time they actually were applied properly. So likewise, Einstein's work wasn't overturned by the discovery of quantum mechanics. Each of these new ideas simply added to what we already learned. So this is because the theories of Newton and Einstein were incomplete theories, in quotes. Incomplete theories, they aren't wrong, but they do not apply to all situations, just like Mr. Newton's theory. This is usually because scientists don't have enough info to actually expand on how the theory at the time was formed. So put yourself in Mr. Newton's shoes. How much info do you think you would have about gravity in anywhere other than the Earth in the early 1600s? So sometimes you have to give him credit. So the importance of these modifications. Theories in science are proven not only to the extent that the results of the studies used to test these theories can reproduce the same results. Scientists construct a hypothesis and then test the hypothesis with experiments. If the results of the experiment disapprove the theory or disprove the theory, that gives the scientist new information. The scientist then uses that info to revise his hypothesis and test his or her own revised theory. Scientific theories are always held as provisional. If more evidence or a better theory comes along, they can be refuted. This is unlike, let's say, religion, where certain statements about reality are held as immutably true. Scientific theories are generally just well thought out guesses. So as new data emerges, they are either tossed or discarded in favor of better explanations, or they are adjusted to make them a better fit because of newly available evidence. Science is an ongoing process of refining and sometimes replacing theories as we learn more about the universe in which we live. So more information about the modifications, it's important because as new info comes along, the way we think about theories, they actually change. So as they change, they get modified. So that makes it important to keep up with the new knowledge and to explore the new possibilities or of the modified theories. So as we know, a theory is a revised scientific evidence. Our theory is revised as scientific evidence until evidences are brought to light. So these are references. This concludes our presentation. Thank you for listening.
Thank you very much, Group 1. Our thought out research of the question. There are some things that I would want to speak about, and they came out in the presentation. I'm opening the floor just to give a little breather for maybe about 5 minutes, no more than. Are there any questions to the group? Any questions? All right, so there's just a comment that I'm going to be making. So Asia spoke just now about how much information Sir Isaac Newton had in terms of solidifying his findings, and when Sir Einstein decided to refute some of those ideas, a thought came to mind. How much information are you going to be having for your exams? It's very important for you to read and read widely. One of the things that I was able to see happen in the presentation is that persons were able to read more than what Sir gave in class. What I'm happy about is I don't remember, and if you do remember, you can unmute and let me know. When I spoke to you earlier about the geology of Jamaica compares to the geology of Cuba, Hispaniola, and those other countries. Anybody remember that one?
Yes, sir. Yes, sir.
All right. Did that come out in your presentation just now?
Sorry, can you repeat what the question?
No, my question, well, not a question really. My statement really was, I remember speaking to you about the geology of Jamaica compares with the geology of Cuba, Hispaniola. You remember me saying that, right?
Yes, sir.
Right. So I'm saying to you, did you see that come out into their presentation? Any at all?
So like if we compared it to other different Caribbean countries?
No, man, remember they're talking about the theory and the breaking away of the different continents.
Yes, sir.
Right. So so it supports the fact that based on what literature is suggesting, that we were all clumped together until we have these plate tectonics, these catastrophes that would take place or would have taken place. And I don't want to get into it because catastrophism, uniformitarianism is going to be discussed now. But it's just to highlight that point that came across in the stuff that I don't want you to think that when I speak, is that there is no evidence to it. They brought that evidence out in terms of the catastrophes that took place, the earthquake, the plate tectonics, you name it, are things that would have caused a separation. And if they were able to pull those continents together, it seems that it would form one massive lump. Everybody saw that in the presentation, true or false?
True.
Yeah, man. So it is important. It is also interesting, and I sat down and I laughed because I'm saying to myself, and I mean, it's a good laugh, of course, to say to myself, it is all here. It is all here. So we recognize that there is an issue. Now, before we can bring, I don't want to get too much into it because, before we can move further into what took place, we now need to look at some other areas. They spoke about three areas, and catastrophism is one, uniformitarianism is one, and they spoke of another one. All right. So what I'm going to ask them, because I only have two other groups, and I asked group number 2, sorry, to look at catastrophism and their proponents. These catastrophes that took place and their proponents, Michael James, Danica Marshall, Alexa Montague, Janelle Raymond, and Benica Reed, will walk us through catastrophism and their proponents. We're going to sit back, relax, we're going to listen to what it is that you're saying, because all three groups will have components coming together. So it is that we can come to a final conclusion at the end of the presentation. So group 2, please, can you go ahead for me? Can you stop sharing for me, please, group 1? Thank you very much, group 1. Job well done.
Thank you, sir.
Good evening to everyone on the platform. Our group will be presenting on catastrophism, and my group members are Denisa Marshall, Michael James, Venica Reed, and myself. That is for this slide. Catastrophism. What is catastrophism? Catastrophism in geology theorizes that the Earth was largely shaped by sudden, short-lived, violent events, possibly of global scope. Catastrophism is a doctrine that explains the differences in fossil forms found in successive stratigraphic levels as the result of repeated cataclysmic occurrences and new creations. To simplify, catastrophism is a theory that changes in the Earth's during geological history from sudden violent and unusual events. That's it for this slide. What is catastrophism? Continued. A catastrophe may have been, for instance, a colossal volcanic eruption, a comet or asteroid impact on Earth, the burst of a large glacial lake's dam, or a very powerful earthquake. A catastrophe theorist, for instance, might claim that the Rocky Mountains were formed by a powerful earthquake rather than by imperceptibly slow uplift and erosion. In the 17th and 18th centuries, catastrophism emerged. That's it for this slide. I now hand over to Denise and Marshall.
So the proponents of catastrophism. So this doctrine is most commonly associated with the great French naturalist Baron Georges Cuvier, 1769 to 1832. Cuvier stated that different groups of fossil organisms were created and then became extinct as the result of geologic catastrophes, the last of which was the Great Flood described in the Bible. So many of you guys may know about the Great Flood that happened in the Bible with Noah, and the whole earth was flooded. So many of you guys may be familiar with that. Each catastrophe, according to Cuvier, killed the fossilized organisms and deposited the sediment that solidified into the rock surrounding the fossils. The concept of catastrophism has been revived with the discovery of large meteorite impact structures and evidence of mass extinction in the fossil record. The most notable of these events was the asteroid impact, marking the boundary between
Cretaceous.
Thank you. Cretaceous, tertiary and tertiary periods between 35 million years ago, which coincides with the extinction of dinosaurs. In essence, Cuvier believed that the worldwide flood in the days of Noah was due to a catastrophic event forming the present-day surface of the Earth, and also the formation of the Rocky Mountain was due to an earthquake. During the 17th and 18th century, catastrophism was the dominant geological paradigm.
So one specific supporter of catastrophism. So a passionate supporter of catastrophism was Abraham Werner, the leading geologist of the 18th century. So Werner was the most influential supporter of Neptunism, which was a theory stating that most of the rocks observed at Earth's surface were once precipitated out of a vast ocean. Therefore, Werner used catastrophism as evidence to prove that the Earth had experienced mass floods throughout geological history. However, both catastrophism and Neptunism would eventually be discarded during the 19th century. As my fellow group member explained, was most dominant in the 17th and the 18th. And now we'll be exploring the history. Pardon, sir?
Good evening.
Hello?
Lenny, can you continue?
Yes, I'm continuing.
So now we'll be exploring the history of catastrophism.
I'm sorry, Benita, I'm so sorry to disturb you. Is there any possibility you could turn that volume down a little bit in the background, please?
Oh, one.
Thank you, Tom. Appreciate it.
Okay, any better?
Yeah, that's
Yes, Dan.
Perfect.
Yes, Dan.
So exploring the history of catastrophism. So catastrophism was a theory developed by Georges Cuvier based on paleontological evidence in the Paris Basin, and paleontological refers to fossils, basically fossils that are found on the Earth's surface. So Cuvier was there when he observed something peculiar about fossil records. So instead of finding a continuous succession of fossils, Cuvier noticed several where all evidence of life would disappear and then abruptly again after a notable amount of time. Now, Cuvier recognized that the process was not finished. So this led Cuvier to develop a theory called catastrophism. Now, catastrophism states that natural history has been punctuated by catastrophic events that altered the way life developed and how rock. Now, and to
Evidence of catastrophism. Now, Hoover hypothesized that flooding of lowland areas could have been the cause of mass extinction. And as we know, mass extinctions are when abnormally large number of species die out within a limited period of time. Now, go back, slide before. The slide before, go back, yes, that's one. All right, one slide forward. Thank you. Go back to the one with the photographs. That's it. So these are examples of catastrophic events. Volcanic activities, flooding, earthquakes, all are responsible for what is deemed as catastrophic events, and was once believed that these events were responsible for the mass extinction that followed, and also that contributed to the formation of all landforms. Next slide. Now, as we all know, there is a consensus that in the past, dinosaurs have been extinct or went into extinction because of a meteorite strike that altered the environment, which led to the extinction of that group. And as you know, mass extinction is a large amount of a particular species being killed in a limited time period. Now, on your right, there is a presentation of deposition. As a paleontologist, Hoover would have worked with fossils, and one of his main studies were with elephants, prehistoric and current and modern elephants. And by doing so, he realized that there was a vast distinction in the structure of both and the size. Now, his discovery were based on the fossils being deposited in different sublayers, as you would see here with the graduation of deposits on your right. And the possibility for such finding of a group of fossils within a sublayer would stratigraphic, I don't remember the word, but the sublayer, yeah, the sublayers would demonstrate that within that time zone, you would have had an event that would have caused for these animals or this species of animals to have died. And thus he was able to put these animals or species in different geological time zones. So from the Mesoic period, which would have been the midlife, the Paleozoic, which is the ancient life, and the Cenozoic, which is recent life. So based on these fossil records, he was able to bring forward the theory that yes, some catastrophic event had led to these extinction. So the next slide, please. But there are some drawbacks to the theory. And the two main drawbacks are that the theory was driven by theological perspectives. So you know the Noah flood, rather than a scientific perspective. So no actual scientific at the time was implemented or underwent so that the theory could have been proven as fact. And also, Coover did not explain the driving force that caused these great catastrophic events to happen. Next slide.
Okay, now
Here's a short video.
Yeah. Mm.
Share the sound.
Share the sound. Share the sound.
There is no sound?
No.
All right.
That Earth was shaped by.
Are you hearing it now? Yeah.
Yep.
Okay.
Violent sudden events like super volcanoes, not just ordinary earthquakes, but mega earthquakes. And of course, the sudden, violent, mysterious mountain building events caused perhaps by contractions of Earth as it cools. All of those events would be catastrophic. But the catastrophist's favorite catastrophe by far was the mega flood. Huge floods that cover vast areas of land, well, those would be catastrophic for sure. An interesting side note, up until the 1800s, scientists did not believe in the idea of extinction. At that time, people reasoned that the universe was created by a higher power that did not make that a mistake. Mysterious tooth found in France. The tooth looked an awful lot
Group 2 is all is well. So I don't know if it's me, but I'm not hearing a thing.
Yeah, we're not hearing.
Benicio?
Sir, I
Okay.
don't know why you're not hearing. I'm trying to fix that problem.
All right, never mind. It's all right. Move on from this video. Just make sure that you send the video so they can watch it at some time later. Move on from the video and continue.
Is anyone hearing me?
Hearing you now.
Okay, that is the end of the presentation. Sorry for the video, but it will be shared so you guys can watch it for yourself and get an understanding. Thank you.
Thank you, Group 2. Again, very well done. One of the things that we need to be very mindful of is, and you'd have heard me speak about this many times over in terms of having some levels of backup should in case something goes wrong. No fault of yours, it's just the technology. Whenever we're in this space, these are things that will happen. So let me give you one good and quick suggestion for combating, a delay such as this. All the group members, if you're doing another group presentation, all the group members should have a shared copy and have the copy running simultaneously when the presenter is doing the stuff. So should in case that presenter has a difficulty, that presenter should just go ahead and just stop sharing, and then another group member picks up. So even if Venica is presenting from her screen and it goes, she should have stopped sharing. Michael should be there at that point because he's following what is happening and should go ahead and then start the navigation. Am I clear? Are you hearing me?
Yes, sir.
Yes, sir.
Yeah. So that it minimizes, because you don't want to break the flow. I mean, very good presentation, but when the thing wasn't playing just now, it's like, oh, come on, right? So in order for that to happen, and I've said it to you over and over, so this is why when I'm having a class, I will say to you that sometimes, and it has happened twice to me before, where I'm using my data, and then the data decides to act up, and then quickly I have to switch over to my Wi-Fi. So at any given point in time, whenever I'm having class, I'm there twice, right? Once I'm presenting, I am there twice. Should in case one system decides that it's going to freeze up, I just move to the other system. I may move to the other system, but because it's frozen and I can't stop share, it means that I can still engage the class at some point in time. But these are things that will happen. And I'm telling you something that will take you in not beyond the gates of Excelsior Community College. When you would have moved out into your organizations and you're conducting your Zoom meeting, because it must be Zoom they stay with it for life, don't? Yeah, man, not because of COVID, but Zoom they stay with it for life. So when you're having your Zoom meetings or your team meetings or whatever other meetings that you're using with technology, should in case something like this happens, you should be able to use multiple devices so that at least this should happen. And also, if you are doing any form of presentation using the technology, always have a printed copy by your side. Matter of fact, let me scratch that. Always have several printed copies by your side. All right. I'm emceeing the graduation now. It's not the last graduation, the graduation before. And because I go by that theory, I did about 3 copies of my running order. And bam, as I got into the place, oh, sir, can I see your running order? And then I was ready for my running order and somebody went to photocopy my running order. And if I had only 1 copy, I would not have been able to do my final preparations, right? So sometimes somebody may want to look at something, somebody who is very critical to the program may want to look at something. Maybe your CEO may be asking you a question and say, Venica, let me see what is happening. and your CEO believes that that was his copy. Now you want to present, and you're not going to look like no fool, and you don't want to go to the CEO and say, "Give me back my paper." No, because you want to work. You understand? So you have to make sure that you have a lot of backup, and it goes for everybody. It happens to me in other events. I don't want group to think that I'm very nice, very nice.
Sir,
Go ahead, honey.
sorry to cut you, but I was there presented. Everything was going smooth, and the video was playing on my end. But unfortunately, Zoom kicked me out to authenticate. So when the video ended, and I was like, okay, and here's the reference for presentation, I realized that there's nobody. There's really nobody.
Yeah, I know, but it's as I said before, Venica, you know, and I'm seeing Lexia, you know, giving an explanation also to me, and I don't want women to move and say, oh, sir, just beat me up, and I never beat up group one. You know, I'm not beating you up. I'm saying this to everybody because as a presenter myself, I have to make sure that safeguard myself against these things because trust me, it will happen. It will happen. I'm doing a function on Thursday of this week. And I'm telling you, I'm working with my data because I'm not depending on the data for that place because today data may not be able to carry my stuff. I'm working with my own data, I'm having my crops, and I will have my physical paper because I don't want to do that. But fair enough. It was well sorted out. I'm happy for what it is that I saw. Now, I started laughing again, just like I did in group one, because when I first started, and I was like, oh, we must pronounce them words with 15 different letters in there, right? And you know, I started laughing because I hear some of you, you know, struggling with the stuff, you know, paleontology, right? Sensoic, stratigraphy, right? So, you know, these are things that, you know, we spoke about. And one of the things that I like, just like I saw in group one, is that group two was able to look at these catastrophes that took place and pretty much using one of those time scales to stratify, which is why he had a stratified graph, to stratify these fossils to name them. So I'm saying to myself, yes, you know, so it's learning is not isolated. Learning is a conglomerate of ideas and putting things together. All right. So I'm seeing the whole business of 65 million years ago with the mass extinction, and it's good. You know, it tells me that, you know, the information that I'm sharing and the information that you are researching is the same information that is out there, and it makes very good sense. I thank you, Group 2, for presenting and putting things into perspective. And I'm trusting that Group 1, you're tuned in, and so far you're making connections with what Group 2 did. Group 3, you're about up, and I'm going to invite you now to go ahead, starting now.
All right, sir, just give me 1 second, let me share. All right. Good night, everyone. Tonight, my group members and I will be presenting on uniformitarianism. The members of my group are Danielia Wright, Kyla Thomas, Kyla Wilson, and myself. We will be presenting on what is uniformitarianism, Horton's rock cycle, who is James Horton, as well as who is Charles Lyell, along with a brief video on uniformitarianism.
So good night, everyone. Can you hear me?
Yes.
Okay.
So what is uniformitarianism? The present is the key to the past. In geology, uniformitarianism is the concept that the present day geologic events mirror the geologic events that occurred in the past, and how these events change and or occurred in the, how these events change and or create topographical features. Some of the topographical features formed are mountains and valleys. The theory
Theory of uniformitarianism. This theory was created by James Houghton, who introduced his principles to the Royal Society of Edinburgh in 1785 and published a book called The Theory of the Earth in 1788. Uniformitarianism is also known as the doctrine of uniformity or the uniformitarian principle.
James Hutton was a Scottish geologist who was born on the 3rd of June 1726 in Edinburgh, Scotland.
Houghton's rock cycle. James Houghton believed that the sediment of rocks due to weathering had been washed off the land into water bodies such as the ocean or the sea to form bed layers which would become solidified due to pressure and heat. He also believed that geologic processes such as volcanism created new surfaces of land from the internal heat of the earth, which birthed new rock formation to the surface of the earth. He believed that these geologic processes were cyclical and based on observations of the duration of these processes, asserted that the age of the earth must be inconceivably great. Major issues in geology, which is time. Kylo.
James Hutton was a Scottish geologist who was born on the 3rd of June 1726 in Edinburgh, Scotland. James Hutton had a keen interest, and as a result, he committed his time to scientific reading, inspecting rocks, as well as observing the natural processes of the earth. Did you know James Hutton was not only a geologist, but a physician, farmer, meteorologist, and an industrialist?
Charles Lyell. The uniformitarian principle became popular in the 19th century by Charles Lyell, who was also a Scottish geologist. He was born on the 14th of November, 1797 in Kinnordy, Forfarshire, Scotland. One second.
What do you see? Well, you probably see what I see. A rock. Gray, brown, maybe a few sparkles. Nothing too exciting. But to 18th century geologist James Hutton, rocks were more than just rocks. Instead, they were the keys to Earth's history. Billions of years of stone shifting, melting, crunching, twisting and reforming. A history that he discovered in a time when most people believed that the world was 6,000 years old. James Hutton was born in Edinburgh, Scotland, June 3rd, 1726. He was a bit of a floater, studying at several universities throughout his youth. This wasn't a big deal. He had a pretty... did have a strong interest in chemistry. He qualified as a doctor and wrote his medical dissertation on the circulation of blood, which he believed correctly, but for the wrong reasons, was being constantly destroyed and renewed. Eventually, Hutton decided that he didn't really want to pursue medicine. He spent some time on his farms, and then he moved back to Edinburgh in 1768 and began to develop his ideas about geology, which also involved renewal and recirculation. In Hutton's time, a lot of people believed that Earth was shaped by catastrophes, like the ones in the Bible. But Hutton thought that Earth actually went through a constant cycle of destruction and renewal. He proposed that rocks and soil are eroded and swept into the sea and then compacted into bedrock before being twisted and turned by enormous pressure. A few years after he first came up with this theory, Hutton discovered evidence for it in a few different rock formations. The most famous of these discoveries was at Sicker Point, a cliff off the eastern coast of Scotland that features layers of red sandstone and great amounts of time and great pressure could have offset the rocks, much longer than 6,000 years. And as we now know, of course, he was right. This feature at Sicker Point and several others around Scotland are called Hutton's unconformity in his honor. He also discovered that granite was an igneous rock formed by the cooling of molten lava, by observing tendrils of granite that had made their way into rock like sandstone, which he realized could only have happened at very high temperatures. Hutton believed that this was strong evidence that there was molten rock below the surface of the Earth, and that this molten rock was constantly pushing outward and then melting again. He published his findings in a paper in 1788, but his theories didn't always gain traction because they often contradicted the idea that the Earth was 6,000 years old. Plus, a lot of other scientists' geological theories incorporated the Great Flood described in the Bible. Hutton's ideas did not. But a lot of his work turned out to be accurate, even though he didn't have access to technologies like carbon dating, which would have put actual numbers on the ages of rocks. Hutton also paved the way for future scientists, like 19th century British geologist Charles Lyell, to develop a theory called uniformitarianism. Uniformitarianism is the idea that the processes that shape the world now also shaped it in the past. So scientists can work backward and figure out what happened in the past. By assuming that natural laws function in the same way across space and time, we don't need major catastrophes to explain how Earth formed. Instead, we can show that it's the result of slow processes over enormous spans of time. Thanks to Hutton, the picture of our world got a lot more complex. He was wrong about some stuff, but many of his ideas helped shape geological concepts that we still use today.
We have come to the end of our presentation. Thank you for listening.
Thank you, Group 3. Thank you very much. All right. Any questions? I'm opening the floor. Okay, yeah. Yes, Montague, I see stuff. Yeah, man. Big up yourself. Are there any questions? Are there any questions? And you can field your questions, from groups 1 through 3. Any questions? Okay. All right. So I want to find out, how do you feel from doing this level of research on your own as a group, to inform not just yourselves but your other teammates? Oh, I forget that I'm muted because you're not hearing me. I know. I just said that to see if people would just respond to me. All right.
Sir,
So go ahead.
More informed.
Oh, you're more informed. Okay, good. Paz, I hear you coming in.
Sir, it was a bit difficult in the sense where I felt like we were not doing the group work together. But in terms of the information, I still feel informed because you know, I was doing the work, doing the research and stuff like that. But in terms of the group work, the input is not really there, to be honest.
And I'm happy you made mention of that because for those of you who don't know, I am the head of STEM. So I pretty much liaise and with my three heads of department, Mrs. Williams, Mrs. McLeod Thomas, and Mrs. Hall Francis. All right. So I double up. Well, triple up. I'm the head of the math department, the head of School of STEM, and the dean of the faculty. So I have had many conversations. So this is my first interaction with you, but I've had many conversations. And there is an elephant in the room that we need to address. Trust me. And you understand sometimes why I say whenever you're touching base with me, touch base with me in the group, because I know I have a responsibility to touch base with my group. I have a responsibility that every day I look for I type in geology and I look at the chats going on and I said, okay, fine. All right, yeah, man, them good, right? This up. I wasn't hearing from my which was my foundation concept 3 class, math class. And I had to send a little reminder to them and I said, oi, everything all right over there, sir? And the man said, yes, sir. And of course, when I went to class on Saturday, I had to cuss them out because they lied to me. Them say everything is all right and they never do my work. So I have to cuss them out, man, good and proper. But yeah, it keeps the brain going though. So I'm a little concerned. I'm a little concerned that, and I'm going to tell you, and this is why I said to you that I wanted every member of the group to present. There are some members who presented and the information was very fluent from their tongue. What does that say to me as a presenter myself? That you did the research and as such, presenting it wasn't difficult. But there were one or two others who were presenting and the information was not so fluent, suggesting to me that you may only be the recipient of a slide or an email, and then you're just going to read from it without giving an explanation. I heard one or two, I heard a few members who had the slide up and was able to freelance. I know they weren't reading. They were able to freelance, and I said to myself, all right, the brother understand. Yeah, man, the sister understand what she had talked about. Because it was fluent, it was freelancing, it was coming out of you because you would have done the research, you understand what was happening, and then you started speaking about it, as opposed to just slavishly read from the slide. And I wasn't so convinced with your reading. And I know you know where I'm going, all right? Suggesting that some of you just were recipients of the information to present. No, this was a trial run. A very good job, I must say. I am very pleased with all the three groups. And if I were to grade this, everybody would say this again. If I were to grade this, the groups all groups would have passed the presentation. And who to tell? I may at some point in time go back, and this is how it works in teaching. You know, sometimes a student may fall short, and you have the recording, then go back and say, okay, the student presented here. Let me substitute one grade for another, for argument's sake, right? So which is why it's very important for you all to participate in this stuff. So I may end up using this presentation, who to tell? But it is very important that when you are presenting, you do a good job at it, irrespective that you have the support from your team members. Because say, for example, group one is to get 80%. Not all the members of group one will get 80%. No, not all the members will get 80%. And if group two is supposed to get 85%, not all members of group two will get 85%. And if group three were to get 90%, not all members will get 90%. Now, you hear what Pat said? I would, when I'm doing my stuff, I will have my secret ballot. And I will say to the group members, rate your group members from 0 to 10, read their participation. And I will look at it, and this is independent of everybody, and I will see what is happening. All right? So though group one got 80%, you may end up getting a 65%, but the other group members may get an 80%. Sorry, you can't do that. Really? I'm saying to you, students, it is important for you to do what it is that you need to do. As it relates to the group assignment, I may come back to, I did this randomly by just looking, and if you recognize, I looked at the first 5, then the other 5, then the last 4. But in looking at it, and based on my observations, I will have to do the grouping maybe slightly different based on something that I'm seeing. Won't tell you what I'm seeing just yet. But for the most part, it was a job well done. It was informative. It don't make sense I present what it is that I have, because I mean, everything that I had to present to you tonight as a summary pretty much came out in the presentations. Very, very, very well done. I'm going to suggest that you all have another look at the presentations. I'm also seeing where groups 1 and 2 have submitted their presentations, waiting for group 3. I'm going to ask that you go through, you look at it. Can I tell you? On the exam paper, there maybe, could be on the mid-semester, could be on the final, something talking about catastrophism, or uniformitarianism, or it may talk about the issues identified. You all need to know. You all need to know. My question to you: who is the backbone of catastrophism?
Repeat the question, sir.
Who is the backbone to catastrophism? Who is the main proponent of catastrophism?
Cover.
All right, very good. And who is the main proponent for uniformitarianism?
And Charles Lyell. Houghton.
Not Houghton. You know, you keep saying Houghton. Houghton.
Oh, it's Houghton.
Houghton, yeah. Right, very good. So, and you know, and as I told you before, so what happened? So Houghton would have, and of course, you know, catastrophism is talking about the different catastrophes that take place, right? An idea is the forming, and I did make mention of you where it is that I found gold in the field in Clarendon. but of course it was on a fool's gold and it wasn't in mineable quantities. And it is believed to be formed from an intrusion, some volcanic eruption that took place many years ago in our geological past. And what it would have done is to bring those minerals from within the Earth's crust up to surface stuff. All right. So that is an example of catastrophism, right? We have our floods, the Great Flood, in Noah's time, and the volcanoes, and there are different types of volcanoes, Peruvian, Plinian type. Some of these volcanoes that shoot way up into different layers of the atmosphere, right? And the atmosphere is layered. When you move up to year 3, I'll talk to you about the different layers in the atmosphere. So you have some of these that move into the different layers, right, of the atmosphere, and then you have some that spread out, that go across boundaries, like the one in recently held in our Caribbean territory, that Barbados too was experiencing remnants of the ash from that volcanic eruption. So catastrophism talks about the different catastrophes that took place. And you recognize, based on the research, that the man them are lick out against catastrophism. True or false?
True.
Yeah, man. So the man them must say, boy, uniformitarianism is the way to go, because uniformitarianism is, as it says, uniform. So once something is uniform, it means that there is some structure to it. Talk truth.
Yes, sir.
Yeah, man. So I can now look and I can identify a student who's at Meadowbrook High School versus a student who's at Immaculate versus a student who's at St. Andrew High School, as opposed to people not wearing uniform like foreign, and you don't know, some of them are schoolers, but you don't know where them come from. So I can now layer uniformitarianism based on some uniformity, because that's exactly what it is, uniformity. And let me ask you, whew, let me ask you, which are you sold on, catastrophism or uniformitarianism?
Sir, me just say uniformitarianism.
Why?
Based off of the theory, it actually makes sense to me. Where what's occurring now is possibly the case where in the past that's exactly how it occurred as well. So to me it makes sense.
Okay. Group 2, this question is right up your sleeve, but anybody can answer it. So group 2, group 3 says that, boy, hear the plan. I am supporting uniformitarianism. Group 2, are you supporting catastrophism or you side with uniformitarianism? Where are you?
I am for catastrophism.
Okay, and tell me why.
All right, reason being, based on fossil records, you are able to date a particular extinct group to a particular time zone. That is one. 2, there must be a cause for such a massive die-out within a short period of time. So the evidence is there to support it. And even today, there are current discoveries that shows that these events actually took place.
So let me ask another question now. So is there a right one? Is there a wrong one? Or both catastrophism and uniformitarianism occur in tandem?
So they both occur.
Say it again?
I would say they both occur.
They both occur. So they work together?
Yes, sir.
Okay. Because if catastrophism wasn't true, what paleontologists would have done over these many years would have been in vain. Is the fossilization is a real thing. real something. So whether it occurred by a catastrophic event, having that sort of mass extinction, where it wiped out all these dinosaurs millions of years ago, there is evidence of fossilized form of these dinosaurs, to the point where archaeologists were able to find, let me not even go where the mummies are concerned, where archaeologists are able to find these bones, the skeletal remains, and literally are able to put them together. Do you believe that?
Yes, sir. Like the mastodons, the dinosaurs.
Absolutely.
Even as that what's the name of that crab? The horseshoe crab.
Absolutely.
Yeah.
No, but remember, as I said to you, geology is closely related to chemistry. And I will talk about that with carbon-14. Biology, when you put in these bones together, locomotion, that area under biology that they study, locomotion, is what it is that we're talking about in terms of putting those bones together. So a zoologist or a biologist can easily move into geology, right? Because the man say, here the plan, medical doctor, something else must happen in yourself. No, man, let us go over here and look at it. They were able to put these bones together. So I don't want anybody to say, no, man, uniformitarianism is the key. And I don't want anybody to go and say, no, catastrophism is the key. What one can do, you may have a question to say, for example, for you to write supporting one over the other. But you have to go put your points together. So Paz, have to go understand and say why it is that uniformitarianism is the key. Mikey, have to go say, no, catastrophism is the key. So you may get a question, you can get a question that asks you to compare and contrast. Can one exist without the other, right? And remember what I talk about in terms of theories, you, based on what you put down, remember, it's not an exact science because you and I weren't there. And the ones that were there are no longer here. And it's not like the Bible that we know that it was written by men inspired by God. There's nothing that I've read in geology that says the history of geology was written by persons that were inspired by the Maker, right? And for those of you who are Christians, there are some things that they will question. And I can tell you, I thought I was going to become a paleontologist. I loved paleontology. When I say I love paleontology, I mean, back then I could identify my fossils. I mean, give me one of them in an exam. I mean, I will go into my practical exam, and the practical exam is an hour, and in 20 minutes I am done because I'm identifying my fossils, I'm drawing my fossils, and I'm doing what I'm supposed to be. Are you finished already, Shand? Long time. This was nothing. But I remember I had a serious argument with my paleontology lecturer, who was this nice young guy who came from the United States. And he said something to me in class. And I said, but hold on there. No, man, but this man, he might go against so me believe. No, man. And we had a serious argument. And he was like, I know where you're coming from, but this is this. And I said, no. I'm going to go to God and I said, God, when me come take upon my hand and do Jesus, and because I wasn't a believer, I shut the man down, right? And I didn't pay him the mind. And I said, okay, what I'm going to do is just to give him back what it is that he wants to hear. And I wrote a lovely essay in that final exam because I know the topic was going to come. So I studied it. And when the man put it up, I say, put it up, I know he put a question there because of when he asked in the class. And when I don't answer that to Simon, man seen and say, wow, you did a lovely paper. I said, yeah, but I don't believe you. Not going to write. I just give it back to you. And I said this to say to you that it's just like what they're saying that some of the theorists are saying that catastrophism don't make no sense because of this. It's, you know, we were having a serious debate in class about uniformitarianism, catastrophism, and people are giving different ideas. And then you had those persons in the class who were atheists, who were saying, you know, some other things that I really got offended and the whole stuff. But the truth of the matter is, as Mikey says, you can't have one without the other. None of us were present. Those who were present are no longer with us to say, true, it did happen. We have to look at it, and there are evidence that we can look at to say, how do you explain the mass extinction? How do you explain the mass extinction? And the final thing that I'll say to you, the mass extinction producing these skeletal remains in a preserved form that archaeologists and geologists could go and biologists too, and put these things together, and chemists by doing the radiometric dating to go back and date to see how long ago these were there. It's what Group 2 said in terms of putting that stratified graph in place. Yes, man. So he was speaking about, he made mention of the Mesozoic and the Cenozoic period, right? So it's a culmination of everything. So it's nothing existing in isolation to something else, right? So everybody coming together, putting their stuff, and you're able to get the stratified graph. And the stratigraphy is telling us that these things happen. And the uniformitarianism now is saying, but guess what? Everything's supposed to be layered, you know. And guess what? The catastrophism is saying it is layered, because when you look at that mass extinction, you may have one layer of all these fossils down here, so, and then as you go along, you may have another layer, because you may have a layer here, and you may have folding of these layers because of another catastrophic event, such as the movement by plate tectonics, right? The liquefied magma under there moving these plates that is separating the different continents. So which is why I'm saying to you that chances are you may be looking for the tail of one of the dinosaurs and can't find it. And so happen years later, many years later, it is found in another continent because, you know, of where it happened. So it's an interesting area. I studied it, and I have a great appreciation of the environment, recognizing what it is that we're walking on. We're walking on a lot of treasure. Anybody recognize that? We're walking on treasure. So if me going to litter the place and not take care of the treasure that I'm walking on, it don't make sense. Think of you having a white carpet in your house. It's not that you're not walking on the carpet, you know, but you're not going to walk on the carpet with your shoes. You ain't go barefooted, or you ain't wear a pair of socks. You know the carpet is going to get dirty, but you're minimizing the damage to the carpet. So we know we have to do things in the environment that was going to denigrate the environment. But guess what? Let us do it in such a way that it minimizes the sort of effect that it has to the environment. We're working on a lot of treasures. And I really want, before the end of this course, that we can find, and I want you to think about it, find something that we can do to learn a little bit more project-wise about the geology of something. Can we look at, you know, for upper level, they talk about the core, the mantle of the earth, right? And incidentally, there is a place for females too. It's not just male geologists we have female geologists too. You see the research that she did in terms of getting the vibrations and in terms of getting the sounds coming off, link with a physicist. A seismologist is very important also, because it is that they are talking about all of what is happening with these catastrophes that are taking place. The Saharan dust is a catastrophic event. It is. And it's so far it is traveling from. And these occurrences are happening even today. So I thank you all for the presentations. I really hope that you guys are feeling so led. Those of you who struggled to participate in the production of what took place tonight, I pray that you feel guilty, and I pray that you will try to make amends, because I am again going to be putting you in groups so that you can get more work done. It was a job well done, and thank you. Any parting comments before we go? Okay, no problem. All right, so thank you, Dandan. All the best, and we will meet on Wednesday.
Bye, sir.
Have a good
Thank
one.
you,
Take care.
Yes,
No
sir.
problem. Yeah, man.
Okay, night, sir.